For ages, humanity gazed at the stars wondering, are we alone? We sent messages into the void hoping for a reply, but the universe remained silent, until now. A faint chemical whisper, not a radio signal, arrived from the constellation Leo. It came from a distant planet, K218b, orbiting a small red dwarf star. This signal traveled 120 years to reach us, a journey that began before most of us were born. K218b is unlike any world in our solar system, massive, mysterious, and hidden behind a thick atmosphere. Thanks to our most powerful telescope, we've finally glimpsed its secrets. What we found has upended our understanding of life in the cosmos. The data suggests Earth is not unique. Life may be common, thriving in places we never imagined. The universe, it turns out, is more creative than we ever dreamed. This is more than a scientific discovery. It's a profound connection to another world. Our story is no longer just about Earth. We are now part of a cosmic narrative. The whisper from Leo tells us the universe is not empty. It is alive. And we are just beginning to listen. The implications ripple through science, philosophy, and our sense of identity. We are no longer the lonely exception. Life may be a tenacious force sprouting across the galaxy. The night sky is no longer silent. We have heard the first whisper of life beyond Earth. How did we detect this distant whisper? With the James Webb Space Telescope, our golden eye in space. Webb is a time machine, peering into the past as it looks deeper into the universe. It can catch the faintest light filtering through a distant planet's atmosphere. As K218b passed in front of its star, Webb captured starlight shining through its atmosphere. By analyzing which colors were missing, scientists decoded the planet's atmospheric makeup, a cosmic barcode. This is transmission spectroscopy, a technique that reveals the invisible. Led by Professor Niku Madhusudan, astronomers targeted K218b, knowing it was in the habitable zone. They expected to find hydrogen, methane, and carbon dioxide, building blocks, but not proof of life. Then, something extraordinary appeared, a faint signal from a molecule that shouldn't be there. Dimethyl sulfide, DMS, showed up in the data. The team checked and rechecked, but the signal was real. With this confirmation, humanity crossed a threshold. We had found the first strong evidence of a biological process on a world beyond our own. The universe had finally answered. Our search for life had a new direction. The cosmos was no longer silent. Why is dimethyl sulfide so important? On Earth, it's only made by life, specifically by tiny ocean-dwelling organisms. When you smell the sea, you're breathing in DMS, the scent of life itself. To find this molecule in K218b's atmosphere, 120 light-years away, is astonishing. DMS is a biosignature, a chemical fingerprint of life. Unlike oxygen or methane, which can be made by non-living processes, DMS is a robust indicator of biology. On a hydrogen-rich world like K218b, it's nearly impossible to create DMS without life. This isn't just a hint, it's compelling evidence of metabolism on another planet. Life there is breathing, eating, and changing its world, just as life does on Earth. This discovery changes everything in our search for extraterrestrial life. We've been listening for radio signals, but life announces itself chemically, simply by existing. The universe may be full of worlds exhaling the breath of life. Our instruments are finally sensitive enough to detect it. The search for life has a new focus, the chemistry of living worlds. We are no longer just listeners, we are now cosmic detectives. The universe is alive with possibilities. What kind of world is K218b? It's a Hycean planet, a massive ocean-covered world with a thick hydrogen atmosphere. Imagine a planet 8 times Earth's mass, wrapped in a dense alien sky. Its global ocean could be hundreds of kilometers deep with no continents, just endless water. The hydrogen-rich air acts as a powerful greenhouse, keeping the planet warm and stable. JWST data revealed not just gases, but strong evidence of water vapor, confirming a true water world. Life could thrive in the protected depths, shielded from space by ocean and atmosphere. Scientists once thought such worlds were too hostile, but K218b has forced a rethink. These planets may be even more stable and life-friendly than Earth. We've discovered a new type of habitable world, one that looks nothing like our own. The universe's creativity knows no bounds. K218b is just the beginning. Could K218b be more habitable than Earth? It's possible. Earth's history is marked by violent changes, ice ages, extinctions, and climate swings. K218b's massive size gives it a thick, stable atmosphere and a deep ocean that regulate temperature. Its climate is remarkably uniform, with fewer extremes than Earth. A stronger magnetic field and deep water offer superior protection from cosmic threats. Life there may have evolved in a stable environment for billions of years, uninterrupted by catastrophe. Without mass extinctions, evolution could have taken a smoother, perhaps more complex path. We've always seen Earth as the ideal, but K218b suggests true Edens may be ocean worlds with hydrogen skies. The universe may favor stability over chaos. Our model of habitability has changed forever. A planet's habitability depends on its star. Our sun is bright but short-lived. It will one day end life on Earth. K218b orbits a red dwarf, smaller, cooler, and far more stable. Red dwarfs are the most common stars, and they burn for trillions of years. K218b's thick atmosphere distributes heat, preventing extreme temperatures even if the planet is tidally locked. This means the entire world could remain habitable. Life on K218b isn't on a ticking clock. It has eons to evolve and thrive. Red dwarfs offer the most stable, long-lasting cradles for life in the universe. The story of life there could last far longer than on Earth. The true cosmic Edens may orbit these quiet, enduring stars. The universe's retirement homes are full of potential. For decades, we searched for Earth-like planets, rocky worlds in the habitable zone of sun-like stars. K218b forces us to rewrite the rulebook. Life can thrive on massive water worlds with hydrogen atmospheres, places once thought impossible. The presence of DMS shows biology adapts in ways we never expected. The habitable zone is more complex than distance from a star. It includes size, mass, and atmosphere. This expands the number of possible life-bearing worlds dramatically. We're no longer searching for Earth's twin, but for life in all its alien forms. The universe is not limited by our imagination. K218b is proof that life can flourish in the most unexpected places. We stand at a turning point in history. The discovery of life on K218b is as profound as learning Earth orbits the Sun. For the first time, we know we are not alone. This changes our perspective on everything: science, philosophy, and our place in the cosmos. The James Webb Space Telescope made this possible, a triumph of human curiosity and collaboration. Now, the search for life will accelerate, with new telescopes and new hope. K218b is our template, our proof that the search is not in vain. The galaxy is likely filled with life. This discovery unites us, reminding us we are all children of the stars. The night sky will never look the same. When you look at Leo, remember, something is alive out there. If life is there, it could be anywhere. The universe has spoken. Its first word is life. The revelation of life beyond Earth is not the end of our journey. It is only the beginning. As we gaze outwards, the cosmos now beckons with fresh urgency. Humanity stands ready to chart the cosmic frontier, forging new tools and missions that will take us further than ever before. Across the globe, engineers and scientists are already designing the next generation of telescopes, machines so powerful they will peer into the atmospheres of distant worlds, searching for the telltale signs of life. Space agencies are plotting daring robotic missions to probe the moons of our own solar system, like Europa and Enceladus, whose icy crusts may conceal hidden oceans teeming with possibility. Technology is advancing faster than ever. Artificial intelligence is helping us sift through mountains of data, revealing patterns and signals we might otherwise miss. Soon, interstellar probes, small, swift, and smart, could be launched towards the nearest stars, carrying our questions across the light years. But the search is not just scientific, it is a quest that stirs our imagination and unites us as a species. We are no longer explorers of Earth alone, but citizens of a vast, living universe. Each discovery draws us closer to answering the oldest questions. Where did we come from? Are we truly alone? As we chart this new cosmic frontier, our journey is guided by curiosity, hope, and the unshakable belief that somewhere, out there, other eyes may be looking back at us, wondering the very same thing. The universe has opened a door. Now, it is up to us to step through. What lies beyond the frontier? As the universe reveals its secrets, the impact on humanity will echo far beyond the laboratories and observatories. Imagine a world where the discovery of life elsewhere reshapes our philosophies, our faiths, even the stories we tell about ourselves. Borders may blur as nations unite under a shared identity, not just as citizens of Earth, but as members of a cosmic community. Technological revolutions will follow in the wake of our curiosity. The drive to reach distant worlds could yield unimaginable advances. propulsion systems that shrink the vastness of space, materials forged to withstand alien environments, and artificial intelligences that learn and evolve as our partners in exploration. The exploration of other biospheres may unlock new medicines, novel ecosystems, and perhaps new ways of thinking entirely. But the greatest transformation may be within us. As we gaze into the cosmic mirror and find reflections of life, we may come to see ourselves anew, fragile yet resilient, unique yet part of something much greater. The boundaries of us will expand, and our sense of purpose may deepen. The knowledge that we are not alone could inspire a new era of stewardship for our planet, a renewed drive to preserve the only home we know, as we prepare to greet others among the stars. The universe is no longer a silent void, it is a canvas of possibility. As our horizons unbind, so too does our imagination. The next leap is not just a step into the unknown, but a stride towards our own becoming. The future is calling, and for the first time, humanity is ready to answer, not as wanderers lost in the cosmos, but as explorers, dreamers, and one day, neighbors in a living universe.